Good morning. Right now, I will give you a revision on lecture 4, which is about force and Newton's law. So basically, I believe every one of you know that Newton's second law, which is sigma F equal to ma. A better one is by including the vector. The summation of the forces, or which means that actually we can also put it as F net equal to ma. But somehow, the problem is, how do we use this one? How do we analyze the question? So, before I move further, let me give you one simple example. In this case, let's say there are several forces here. By default, definitely there's a normal force, which I put it as Fn. Then there's a W, which is weight, or you can put it as mg. And then let's say I apply a F pushing here, and this F pushing, let's say, is 3.0 Newton, and the block here is 2.0 kg. So I push it to the right. Then the question is, what is the acceleration? So for this case, since the force is a vector, then we can split into y component and x component. Whereas for the x component, first try to think, is there any movement? And for this question, logically you know that if I push it to the right, which means that as a result, the block is moving to the right with an acceleration of a. So which means that for the y component, no movement. So y component, no movement. If no movement, then we can consider that sigma Fy is 0. 0 indicates either it is static or it is moving at a constant velocity. And for this case, because it is static, then we put it 0. And with that, I can say a vector Fn, bear in mind, is vector, plus vector W equal to 0 vector. Then this one, I can put it as a vector. As I say, it's a plus, and then this is actually a vector. But we need to find out the magnitude, which is more meaningful for us, the magnitude of each vector. So let me consider upward is positive, then I can say plus Fn, downward is negative, then minus mg equal to 0. With that, Fn equal to mg. This is something what you learned in SPA last time. But somehow, right now, I tell you how to get this equation. And basically, if you really observe, somehow I can also put it as mg minus Fn is equal to 0. And more or less just the same. Basically, it's because what kind of reference that we use. If we say that, in general for the vector, we say that if it's moving outward, then we put positive. It's moving downward, which means the direction is downward, then we put negative. So in this case, whereas in this case, we choose that downward is actually positive and upward is actually negative. Then, anyway, that one is not so useful. Let me move to the second part, which actually our target is to find out what is the value of A. Then in that case, sigma Fx equal to, it is no longer 0 because there is a horizontal movement, and this horizontal movement has an acceleration A. So we can put it as ma. Again, how many forces involved? Actually, it has only one force for this case. So I can put it F pushing equal to ma. And bear in mind again, this is just a vector. In order to get the magnitude, again, I will consider that to the right is positive. Direction, if it's to the left, then it's negative. So for this case, I can put it as plus F pushing equal to ma. So A equal to F pushing divided by m, which is 3.0 Newton divided by 2.0, so it's 1.5 meter per second square. This is a simple example that similar to the SPM standard last time. Whereas if I move further, let's say I say that the surface is not smooth, there is a friction, which means that there is a FFR, and this FFR indicates a frictional force. The first thing you must remember, frictional force always against or opposite direction of the applied force or the final movement. So if the final movement to the right, your applied force to the right, the frictional force to the left. Okay. So now, let us analyze this question. Second case. There is a friction. Then we must consider the frictional force. For the y-axis or y variable, y direction, there is no change because W involved, Fn involved. So basically, we still can use this formula. But somehow, for the x direction, it is still the same thing. Sigma Fx equal to ma. So, but somehow because FFR involved, so we must include the effect of FFR. So, let me write it. Vector. So just now I say F pulsing. On the other hand, there's a FFR. Vector FFR. So, in terms of magnitude, then since FFR moved to the left, I can say that it's a negative FFR. So negative FFR plus F pulsing equal to MA. So as a result, F pulsing equal to A equal to F pulsing minus FFR divided by M. So which is minus FFR. So maybe you will ask, what is the formula of FFR? And then let me move further. FFR basically is just mu Fn. Fn stands for normal force. So you have two types. One is FFRS. If the object is static, no movement, then that is mu Sfn. On the other hand, if the object is moving, then we must consider FFR K, kinetic. S stands for static, K stands for kinetic. So the formula is mu K Fn. Fn both have the same Fn, but mu S versus mu K, basically mu S is greater than mu K, no matter how. So, which means that if the object is static, then the frictional force is normally larger than the kinetic force, and it depends. So, once your applied force is greater than the frictional force, then you can move the object. And once the object is moving, then it turns to kinetic frictional force. So, that is a simple introduction on the force and Newton's law, whether it is equilibrium or there is a final movement. And now, let me give you some tougher example, a ramp. It's a question that is related to the incline or ramp. Incline or the ramp. That is a common question in the test and final exam or even tutorial. So, let's say there is an incline like this, and there is a theta here. Nobody will say like that. So, there is a block here. So, for this case, how many forces involved? All the time there's Fn. All the time there's mg. And it depends whether there's a frictional force or not. And for our study, we will consider all the time it has a friction unless we state that it's a smooth surface or no friction at all. Okay. So for this case, if we do not apply any force here, we just have the natural force like a normal force at mg or weight, then which means that we can predict that the object is moving down. So let me put it as the x direction is parallel to the surface, the incline, and whereas the y direction is like this. Okay. So we can cut it this one into two, or we can resolve the mg into two components. First is here, and this is mg sine theta, and the second one is here. This is mg cos theta, which means we resolving this mg, and this mg is no longer useful for us, but we have two components. So again, maybe I ask you, what is the final acceleration? If I say this mass is 2 Newton, 2 kg. So what is the final movement? And further, I ask, if I give you theta equal to 30 degrees, and I say that there is a frictional force where mu s is 0.01. Sorry, mu k. Maybe mu k is better because we consider maybe that's a movement. So for this case, mu k is 0.01. Actually, basically, it means that the frictional force is very small. But doesn't matter. We can try to do it. So we assume that the final movement is moving down. Okay, since mg sine theta maybe is quite large, and then we try to do. So the y component here, again for the y component, sigma fy equals 0 because the object is moving down, no upward, no downward. Okay, so there's a no vertical movement. Then we can say that Fn plus mg cos theta equal to 0, and in terms of magnitude is Fn minus mg cos theta equal to 0. Hence Fn equal to mg cos theta. So this is something different from what you study in SPN. Normally we say that Fn maybe is just mg, but here you can see that Fn is mg cos theta, totally different. And let me move to the second part for the x-axis or x direction. Sigma fx equal ma. So we consider positive if it is moving to the right. And here we can consider this to the positive, and x also go to the right. So mg, let me make it, so mg sine theta minus ffr is equal to ma. This is the magnitude. So as I say, to the right is positive, to the left is negative. So the final movement we assume is to the right, so we put plus ma. Then we get this one, and we continue mg sine theta minus mu k fn is equal to plus ma. Continue by mg sine theta minus mu k. Fn is mg cos theta, so mg cos theta plus ma. Sorry, equal plus ma. Basically, this is an analysis for Newton's law for this case, and we will still consider this is a simple example. Let me make it tougher. On the other hand, there is a pulling force here, and this pulling force has a degree, let's say 20 degree above, the direction is 20 degree above the incline, such a way. So how do we do that? Again, the same thing. Let's say the object is still moving down, then we can resolve the F pulling into two components, the Fx and the Fy. So let me continue. Still the same thing, sigma Fy equals 0, and Fn plus mg cos theta plus F pulling sine theta equals 0. And then we can put it F pulling in terms of magnitude sine 20 degree plus Fn minus mg equals 0. Why? F pulling, the y component of the F pulling is upward, so we consider positive. So as a result, Fn is mg cos theta minus F pulling sine 20 in this case. So how about the x component? Still the same thing. it is moving to the right, or in the actual way we say it's moving downward. So sigma Fs equal to MA. So plus mg sin theta minus Fl plus F pulling cos 20 equal MA. Then as a result, it's still the same thing. F pulling cos 20 plus all the value. So you can see that all the time, no matter how, as long as you know how to use either sigma F equal to 0 or sigma F equal to MA, then you can solve the problem. Then with that, I think I finished all these simple example. Let me give you some tougher example, which involve tension. So whenever it involves tension, basically I think students quite confused, and it's better I give you some example in this case. And bear in mind, for this chapter is all about forces and also Newton's law. And in terms of calculation, we involve a lot of the vector. So please try to study the vector well, so that you can score this part. Let me move further. If I say this is a pulley, let's say, or hanger, and I say this one is massless. Normally massless indicate frictionless. Frictionless indicate you can ignore this part. Okay. Let's say object A and object B is hanging such a way, and the string and also the pulley both are massless, which means we can ignore the effect of the friction along the path here. So let's say A has a mass of 2 kg, 2.0 kg. B has a mass of 5.0 kg. Logical thinking, when we hang such a way, B will be moving downward, whereas A will be moving upward. And for this case, then we can say that there is an acceleration downward here, and A experiences an acceleration upward. And basically, because they are attached to each other, so the acceleration of B is same as acceleration of A. The only difference is the direction of A. But in terms of magnitude, it's the same. So try to analyze. First, for the string itself, it has a tension. And this tension, we need to consider both parts. A general rule, the tension is always away from the body. So there is a tension here, and there's a tension here. And looks like these two tensions cancel each other because this is along the same string or same cable. So let me move forward. For object B, we use sigma. For this case, we just involve a y direction, so we can put it as sigma Fy equal to MA. And to make it simple, for this case, we consider downward is positive, which means upward is negative. As a result, MBG minus T equal to MBA. How about T? We don't know. In order to analyze this question, we further move to the object A. And again, for object A, it's still the same thing. Sigma Fy equal MA. Excuse me.